The last thing we're going to look at are powers of I. And so we're going to start with our simple case, I to the 0 equals 1, because anything to the 0 equals 1. You have an imaginary number. If we multiply both sides by I, we're going to get I to the first equals I. So on the left, I'm going to write the I to a power. On the right, I'm going to simplify it. So we multiply both by I again, we get I squared, and of course we know I squared is minus 1. And I cubed is minus I. Well, I to the fourth is minus I squared, which is a negative 1, and negative times a negative 1 is a 1. And notice that we've looped around. This means as I keep going, I'm going to recognize that every 4, I'm just going to repeat the pattern. So it repeats every 4. And so there's a couple of ways we can do this. We can rewrite into powers of 4 times whatever's left over, or we can rewrite into I squareds, or we can use our calculator to find these. And I'm going to show all three methods on the following problem. And then I'm going to stick with this one because I like it most, but I know some people like the others, so I want you to see them. So suppose we have I to the 27. So what we want to do is we want to take the 27, we want to pick the number that's a multiple of 4, but smaller than 27. So that's 24, which is 4 times 6. So we're going to rewrite this as I to the 4th raised to the 6th power. And that leaves 24, but how many are left over? I, 27 minus 24 is 3, I cubed. So I to the 4th is 1. So anything to the 1 to any power is still 1. So I can completely ignore my I to the 4th, and then I just have to evaluate I to the 3rd, which is minus I. So that's the fourths method, the I to the 4ths method. The I squared method does the same idea. The highest even number under 27 is 26, which is 2 and 13. So this is minus 1, because that's I squared. Let's write it in. I squared to the 13th times, there's an I left over because 27 is odd, I to the 1st. Well, this is minus 1 to the 13, and a negative to an odd power stays negative, so this whole thing still resolves down to I to the 1st. The last method, the one I prefer, is I just take the power and I compare it to the following. So this is the remainder. If there's no remainder, then it's 1. If there's a 0.25, it's an I. If it's a 0.5, it's a minus 1. And if it's a 0.75, it's a minus I. Notice this lines up to I to the 0, I to the 1st, I squared, and I cubed. So when we grab our calculator, we do 27 divided by 4, and we look at the remainder, 0.65. 0.75. 0.75 is minus I. And so all three methods give the same answer. It's just a matter of picking the one that you like best. I better demonstrate all of these again. So let's look at I to the 38th. So the highest multiple of 4 under 38 is 36. 36 is I to the 4th times 9. Well, 38 minus 36 is 2, so that's going to leave 2 left over, I squared. So this we ignore completely because I to the 4th is a 1. We just get an I squared, and we evaluate I squared to be minus 1. Well, that's our fourths method. Our squareds is I squared. 38 is 2 and 19. So this is minus 1 to the 19th, which is minus 1. There's no i's left over because this is an even number. Or we take our 38, divide it by 4, and get 9.5. 9.5, the only part we care about is the remainder, and so that gives us minus 1. So pick your favorite method, stick with it, and just know that they keep working the same way. Now the only thing you have to be careful about are negative powers. So let's say we have I to the minus 13. Remember, this is the same as 1 over I to the 13th. And I to the 13th, let's use our calculator method, is a 0.25. So this is really 1 over I, and we don't like that, so we multiply by a negative I over negative I. And this becomes negative I over negative I squared, which is minus a minus 1, which is a positive 1. So our final answer is just minus I. So remember, you have to move it to the bottom, then evaluate it, then rationalize it, and that'll help you get your answer.